Hey guys, so this is the lesson for 5.4, and in this lesson we're doing the sum and difference identities for sine and tangent this time. So it's pretty much just like what we did in the last lesson, but we're using sine and tangent. The sine, if you look at the identities are obviously different, but the sine formulas are similar to what cosine was, in that it's like timesing two things and adding or subtracting two other things many times. But the tangent formulas are completely different. They're fractions. And they only involve tangent. So just be aware of that. You do have your reference identity sheet, so we should be good. So like I said, the idea behind all of this is pretty much doing what we did last class. Okay, so let's take a look at our first example. So we want to find the exact value, and they gave us the sine of 75. So first we need to figure out what are two angle measures of our special right triangle angles, unit circle angles, that we're adding together to get 75. So, or you could subtract some if you want to do it that way. I usually like to do the adding instead of subtracting just because it's, well, I guess it depends on the angle measure, but the one that sticks out for me for this one is 30 and 45. So this would be the same as sine of 30 plus 45. So that's what I'm going to use for my A and my B. So if we're adding, our sine formula is sine of A times cosine of B plus cosine of A times sine of B. So this would equal to sine of 30 times cosine of 45 plus cosine of 30 sine 45. So basically we just switched what angle measure they had. So again, from there we just do what we did last class and plug everything in. If you don't remember your values for 30 or 45, draw your triangles. So the sine of 30 is 1/2. Cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. And sine of 45 is root 2 over 2. So we would have root 2 over 4 plus root 6 over 4. So our final answer would be root 2 plus root 6 over 4. So pretty much just like what we did last class. And if you look at your notes from last class, the first one we did was the cosine of 15. And we got the same answer as this, if you remember. And remember what we talked about, that the complementary angles are always going to be congruent. So 15 and 75 are complementary, and we got the same answer. So that's not a coincidence. Okay, so the bottom two on the front is going backwards. So you need to match them to what identity it is and either add or subtract that value. So why don't you go ahead and pause and try those two by yourself and see what you get. And when you come back, we'll talk about the answers. Okay, so for number 2, if it's minus here, then it's minus in the equation. So that means we're going to do 40 minus 160. And then I added 360 to get the coterminal angle. So that way I could draw the picture. So we get negative root 3 over 2. For number 3, if it's minus here, it's minus over there. So we get tangent of 30, which is equal to root 3 over 3. So if you have questions on either of those, write them down and we'll talk about them in class tomorrow. So let's take a look at what we got inside. So the rest of this is pretty much just like what we did for sine or for cosine, which I've said like 5 times, but I don't want you to get like freaked out because the equations are different or anything. So let's start with this one. Remember on the other one I said it was like the harder one because you have the 2 triangles. So it's same deal here. So let's draw our triangle for A and our triangle for B, and then we'll plug everything into our formula. So it says that A is in quadrant 2. So here's my angle A, and they gave us that sine is 4/5. If we do the Pythagorean theorem, we get negative 3 for the other side. Our B is in quadrant 3. And then they gave us that the cosine is negative 5 over 13. So that means the opposite is negative 12. Okay, so let's take a look at our formula. So the tangent of A plus B is equal to the tangent of A plus the tangent of B over 1 minus tangent of A times the tangent of B. So the tangent of A, if we look in our triangle here, is 4 over negative 3, or negative 4/3. plus the tangent of this one would be 12 over 5 over 1 minus them being times tangent of A times the tangent of B. So negative 4/3 times 12/5. Okay, so from here, it's really just doing order of operations. We're going to have to get some common denominators in the numerator. So I'm going to multiply this fraction by 5 and this fraction by 3 to get my common denominators. So that gives me negative 20 over 15 plus 36 over 15. And the bottom I have 1 plus 48 over 15. So since I need common denominators down here as well, 1 is the same thing as 15 over 15. So I'm changing that. So now I can combine like terms. So that would give us 16 over 15 over 15 plus 48. Sorry, I feel like I did something wrong, but I didn't. Okay, 15 plus 48 is 63 over 15. So from there, we would flip and multiply. So this would equal 16 over 15 times 15 over 63, which those 15s will cancel out. So we get 16 over 63. So that would be our final answer. So this a little more complicated because we got fractions and fractions, but it's pretty much just the same thing. Okay, so for the bottom, we're doing like what we did on the front. So why don't you go ahead and try to find the exact value for 7 pi over 12. Remember I said I would convert it to make it easier to figure out. So go ahead and pause and do that. Okay, so we should get up to this point, I think. We got tangent of 60 and 45, and then we simplify a little bit, so we have this. Okay, so let's look at that part, and I will help you figure out what we did from there. So we get root 3 plus 1 over 1 minus root 3. So the problem here is that we can't leave the radical in the bottom, so we have to multiply by the conjugate and rationalize that denominator. So if we times this by 1 plus root 3, and times the bottom by 1 plus root 3, so now we need to FOIL the top and the bottom, so that would be root 3 plus 1 plus root 3 over 1 plus root 3 minus root 3 minus 3. So combine like terms, we get 2 root 3 plus 4 over, those cancel out, it's negative 2. And then we can divide those, so we end up with negative root 3 minus 2. Okay, if you are having problems with that algebra, make sure you ask in class tomorrow. Okay, so let's take a look at our identity that we're going to verify. So we have a sum here and a sum here. So we're just going to plug into our formula and see if we end up with cosine on both sides, which we will since it's an identity and we're trying to just show that it's right. Okay, so use this as your A and B for that sine problem, and then this will be your A and B for the cosine one, and plug those into your identities. You're going to have a lot of things written out for each one of those, and then they'll cancel out some of the terms, and then what you should have is cosine left. Okay. And then for the bottom, we did one like this. So basically, you're just doing what we did here. Oh, that's the exact same problem. So do that. Okay, so go ahead and pause and try it. Maybe do this one first so you know what you're doing for up there. So write this in terms of theta. So apply your formula. So the sign of plus, this would equal the sine of 30 times the cosine of theta plus the cosine of 30 times the sine of theta. And then you can go ahead and simplify that, okay? And you can use that answer up here and then do the cosine formula. So pause, and when you come back, I'll show you the correct answer. Okay, so at the bottom, you just had to evaluate that. So the sine of 30 is 1/2. Cosine of 30 is root 3 over 2. And that's as far as you can get it. So that would be it. Okay, so if we take that, plug it right up there, then for this, the cosine of 60 plus theta, if we do that here, you get this. The cosine of 60 is 1/2, and the sine of 60 is root 3 over 2. But there was a minus there, so that cancels those out. So those are gone. And then we have 1/2 plus 1/2 is 1. So it equals the other side. And that's it. Okay, everyone, that is all for the sum and difference identities for sine and tangents. That's it.